Welcome. We are going to continue our investigation into inference by looking at how we can draw conclusions, whether a claim is true or not, and how we can deal with null and alternative hypotheses and make conclusions regarding proportions and means. Here we're going to be conducting tests about both means and proportions with two populations and one population. So we have to be able to identify what we're dealing with so that we can then perform the right test. What we're trying to find out here is whether we're dealing with a mean or a proportion or a single or double population, like one or two populations. Remember that means are averages and proportions are percents. Now, the first question says, at this college, we have male students and female students, and they're asking about being more likely to be smokers. And more likely means half. But what they're saying is the probability greater than 50%. This is a proportion, and we're comparing two different populations since we're talking about male and female. Question 2 says, for many years, working full-time was 40 hours a week, on average, I would say. A business researcher gathers data on the hours that corporate employees work each week, and she wants to determine if they now require a longer work week, so that's more. This is a mean, an average of 40, and they're saying, is the average greater than 40 for a single population? It's strictly those corporate people that we're talking about. For question 3, at Mount San Antonio College, do less than half of students exercise at least 3 times per week? Less than half percent would be less than, P would be less than 0.5. This is about a proportion, and we're talking about San Antonio College. That's just a single comparison here. And lastly, learn by doing number 4. Does the type of employment make a difference in how someone saves for retirement? A researcher gathers data on how much government employees and corporate employees put into their retirement each month as a percentage of their income. We are talking about means here, and these government and corporate employees, that's government and corporate employees, which means we're talking about two populations. All right, now notice that in most of these, let's see here, I was talking about means here. I don't know what the value is in terms of what money they were saying that they assumed to be included. But if you notice in the previous 3 problems, I was writing either P or mu, and that's because we're looking at our null and our alternative hypothesis. Our null hypothesis, which we write as HO, is always a statement of the parameter equal to some value. And the parameter is either going to be P or it's going to be mu. So P is equal to a value or mu is equal to a value. The alternative hypothesis is always a less than or greater than statement. So P is, and we can also do a not equal to. So P is greater than something, or P is less than something, or P is not equal to. And not equal to, keywords for that is difference. Is there a difference? We need to be able to write our hypothesis statements in words and symbols, like I'm showing you on the left. So you have to pay careful attention to the symbols that are used. Let's practice that right now. Question number 5 here says, we've got the Centers for Disease Control, the proportions. I'm going to highlight the important words. Proportion means P, and we have the value of 0.22. So that's the adults, proportion of adults. That's going to be our population value. They want to know if it's lower among adults who have a bachelor's degree or higher education level. Then for our null hypothesis then, we're going to say that P is equal to 0.22 because they give us this value. And then when they're saying less than, we use that for our alternative statement. For question 6, they're asking about the differences in mean IQ, which means we're going to be using mu instead of P, between somebody who was raised by their parents versus someone who was raised by somebody else. So parents and someone else, it's 2 different populations. And they wanted to know if there was a difference in IQ level. And remember, I said difference says not equal to. So one way we could write this is say that the null of the 2 populations is equal average, and the alternative is that the 2 population averages are not equal. And I want to warn you that different textbooks use different notation. You will also see mu1 minus mu2 equals 0. These two are the same thing. And the alternative of mu1 minus mu2 not equal to 0, those are equivalent. Okay. Question number 7 says, at Valencia College, are male students more likely to be smokers than female students? So male and female, that's going to be two different populations, and we're talking with more likely, and remember, more likely, we're talking about greater than 50%. So that's a proportion. So the proportion is equal, or is it greater? And remember, P1 minus P2 equal to 0 and P1 minus P2 greater than 0 are the same thing. Okay. Now we're going to get into hypothesis testing and p-values. And in hypothesis testing, there's typically 4 steps that you want to do. I like to use the acronym SPDC. The online OLI actually uses kind of a different setup and way they do things, but I think that I've been using this for so long, it's just kind of second nature that I feel like it's very clear. In the state, you want to state the hypotheses, and you want to identify your parameter. That's either going to be mu or p, and you need to do that in context. Planning is where you should check your conditions. This text really doesn't focus on checking conditions very well. The only condition they have you check is normal, but you should be checking whether the sample is random and if you can use normal calculations. You also should be checking whether your results are independent, but that is not something that is focused on in this class. In the do, you do the math. You calculate the test statistic and the p-value. And then finally, in your conclusion, you're making your conclusion about the claim. We have this scenario talking about cell phone usage for different age groups. So according to an article in 2010, the Nielsen Company analyzed cell phone usage for different age groups using cell phone bills and surveys, and they found significant growth in the data usage, particularly among teens, stating that 94% of teen subscribers identified as advanced tech data users, turning to their cell phones for messaging, internet, multimedia, gaming, and other activities they download. The study found that the mean cell phone data usage was 62 megabytes among teens 13 to 17. The researcher is curious whether this has increased for this age group since the original study was conducted. She plans to conduct a hypothesis test. So I like to highlight the things that stand out to me, and the 94% is the first thing that I saw. But now that I come over here with mean and standard deviation, I realize that this 94% is kind of irrelevant. It's not a proportion problem. For the purposes of this example, she's going to randomly sample 50 teens with smartphones, and she finds that the mean usage for these teens is 75. So that's the sample data. The sample size is 50, and the sample mean is 75. And the sample standard deviation is 45, which is actually, instead of sigma s, we use s of x bar. Since it's greater than 62 megabytes, this sample provides some evidence in favor of the alternative, meaning it seems like there has been an increase. The researcher anticipates that samples will vary when the null hypothesis is true. How much difference will it make? Is there strong evidence? This is the most important thing that we're really focusing on. A p-value, we'll talk a little bit more about error, but the p-value is the probability of rejecting the null given that the null is true. And they showed you this conditional probability in earlier modules. So just to remind you, this is saying we know that the null is true, then what is the probability of then rejecting? In this case, when we're trying to write this in terms of conditional probability, we need to know what the null and the alternative hypothesis are. The null hypothesis was that the mean usage was 62 megabytes. And the alternative was they think it's greater than that. So if we're rejecting the null, that means we're rejecting this, and we're even though this is true. So we're saying the probability of saying that the usage is greater than 62, given that it is equal to 62. which would not be a good thing. This is actually an error of saying, like, if I said that it was greater than 62 when it really wasn't, that's an error. That's a type 1 error, and we'll talk about error in a little bit as well. Suppose the p-value is 0.0023. This probability is 0.0023. What is the chance that you would get results like this extreme, from when the population data is 50? This is really unlikely if their mean really was 62. It would be rare for us to get a 75 average for our sample. So when we get a small p-value, we have strong evidence for the claim, which is the alternative. I'm going to stop here and break up the video.